Now, when we're talking about potential differences, well, when I hold a book up from the floor, that's a potential difference. It's elevated above the floor. Now, when I talk about how far apart those two things are, then I have to give it a sign based off of what I'm actually talking about. Am I talking about the energy required to lift the book up off of the floor? We say that that's a positive input of energy. If I let go of it, it's going to fall to the floor, which is going to be an output of energy. So the book's context of energy is going to change. We can also look at it from the point of view of the energy of the surroundings. When the book is lifted from the floor, I lost energy by putting it in. When I let go of it, the room has gained energy by the blam of the book hitting the floor. The signs are already pretty arbitrary when we're talking about potential differences. Now, it's even more arbitrary when we're talking about something like electron flow. So what we're going to do is we're going to have some conventions to help us with this. So our left electrode, by convention, is going to be hooked up to my negative terminal. So you can see that. I've got my left side connected to the negative terminal. I'll have the right side connected to the positive terminal. Now suppose that when I built this, I happen to have the two solutions on the other sides. Well, then I'd end up getting a negative voltage when I hook all this up like that. All that that's going to tell me is that the electrons are flowing the opposite direction from my usual convention. They're flowing from right to left instead of flowing from left to right. So that's what it's telling us. A positive voltage means that electrons are flowing left to right. Negative voltages mean that it's flowing right to left, which is going to be atypical of our usual convention. So then what we do is, if that's how we actually set it up in our research laboratory, because you obviously don't know which one is going to have the bigger difference experimentally before you do the experiment, right? So you plug it in, you do the measurement, and if you see that you've got a negative voltage, then when you sketch it out in your laboratory notebook, you'll draw it in the reversed format. Or if you are really retentive in your lab, you'd actually go ahead and rebuild the whole apparatus turned around. I'm probably the kind of person who would do that because that's how I keep organized. The key I want to emphasize here, though, because we have so many arbitrary conventions, you need to really enforce rigor and discipline on yourself so that you follow those conventions. Otherwise, you're going to end up getting confused in your readings and confused when you try to solve problems. I also want to warn you that different places that you're doing your readings may handle the arbitrariness of these sign conventions in different ways, and they may handle them at different steps. The key, find the one that you're going to do and always do it that way. And you'll see some great examples of that coming up as we actually start calculating exactly what a voltage will be with different concentrations than our standard states. So make sure that you keep up with that.